So welcome CIS 123. This is our week 7, and we're going to talk about structures today. But before we do that, I just want to mention that this is actually a midterm evaluation week, and for our class, this is going to be cumulative of 3 quizzes that have been already posted. I told you on this website, if you have submitted your quiz and you weren't happy with your results, you can send me an email and I will reset it for you. I would like to practice more, and that's one of the important parts of this class, is to practice with those questions and get a good grade. But anyway, so far 3 quizzes have been posted. If you haven't finished any of them, you have this week to finish them roughly. Any time before this weekend or this weekend will be the deadline, and then the midterm grades will be posted sometimes next week. So that's the plan. What else? I just wanted to go briefly over a few things we've been talking about last week, primarily dynamic memory allocation, just another example of array allocation, and then once we do that, we can switch over to discuss structures as an aggregate data type that we can use in many programming languages, not just C or C++. Okay. I have already started my Visual Studio, which I'm using for our examples in class. If you're using code blocks, the environment is very similar. If you want to try the examples, if you use code blocks, I'm using Visual Studio because that's what people have here on their desktops in the classroom as basically the appliance to use. But if you're using code blocks and if you run into any problems, you can email me and I should be able to help you out over email, even like look at your project and so forth. So anyway, today again decided to continue using Microsoft Visual Studio because we're going to start using more examples in this class. All right, so new project, and I need to choose some location for my project. I prefer shorter locations like this one right here, right? And so as usual, we will begin with empty project. My project name will be week 7 demo or something similar. Click OK, which will create an empty project. And make sure that if you're using Visual Studio, make sure that you select Visual C++. If you're using code blocks, that's your default choice as well. Once we create a new project, I typically wait for the status line to tell me that it's ready and everything is fine, and then go to View, Solution Explorer. You may already have it opened on your screen. I need to move this over here. Let's see, source files. As usual, add new item, and that new item is at least one C++ file. So we're going to say main.cpp and place it under a subdirectory for the source files. That would be my recommendation for any project that you create. Okay, add, so that just adds a file. And some of the things we were covering last week, or at least getting started at the end of the presentation last week, that we mentioned was this, the usual, I will say IO stream, right, and then say include cstdlib, right, and then in main, right, and then return 0 And before we return, we can say system pause so that we don't have this disappearing. If we try to run program without stopping in it, I usually keep at least a single empty line at the end of my of every source file, because that's usually what required by some of the older standards of programs. And what I would like to go back to is the topic of dynamic memory allocation. And the syntax is this. You have the new operator to create, essentially to allocate memory dynamically. You can say new int and specify basically the size of memory block. I don't know, this is probably not a very good variable name, but this is the way you can say, I would like to create this many integers. Actually, let's say element count. That would be more appropriate. Like, how many new elements do you want? In this case, how many new integers do you want? And we're trying to say element count is going to be the element count is going to be in another integer, element count. We're gonna initialize it with something, and then we can say std cout how many integers to allocate, and ask the user. We can use standard input, character input, to enter this from the keyboard, element count, right? And this way we essentially say, all right, this is how we can allocate this block of integers. So what's going to happen is this. What is about to happen is that, of course, we have this memory model that we use all the time in this class. Basically, the memory is made up of memory locations, and one way to look at this memory is to say that these are the values, right? Like 1, 2, 3, 4, 5, 6, 0, 7, 85, and so forth. And these are the addresses, right? So we usually say that in C and C++ world, we waste address 0 and say this is basically a null PTR, null pointer. So essentially, the physical location 0 may exist, but we want to sacrifice it in order to use 1, 2, 3, 4, 5, 6, 7, and so forth as the actual valid memory addresses. Of course, if you open your program in debugger and look at the actual memory addresses for your variables, they will be much bigger, crazier numbers than 1, 2, 3, 4, 5. But ultimately, the entire memory model is like this. So now I would like to erase some of these values and then go back to say that if I basically go back to empty cells or cells with some unknown values in my memory model, then when we say integer element count and create it and populate it and ask user to populate this element count, supposedly this is a variable which is allocated right here, right? So this could be our element count, and I could enter from the keyboard 100, right? So I could enter this value from the keyboard, and this will be populated right here. So most likely this variable is located inside a stack memory segment, which is inside the stack frame given to our main function to execute, right? So main function always requires space for local variables, and that space is normally allocated on the stack. We also mentioned many times that there's a memory area called heap. That's a C name for dynamic memory, or free store, and free store is a C++ name for memory allocation. This is because the memory manager implementation in C and C++ are different. And believe it or not, when you want to allocate your memory dynamically, memory manager gets involved in that process and basically takes care of some basic needs, like telling the operating system that you're trying to allocate more memory. So whenever we say new int and specify the element count as the number of integers to create, that's the syntax, right? So you need to provide basically the data type, which is an integer or a character or a byte or some fancy object like pixel or point or color or window, right? You can essentially use anything in terms of what you want to create as dynamic memory allocation, right? And you use this new operator to say this is how many new elements I want, and say that my 100 integers may be allocated right here on the heap, in the heap memory segment, and there of course are populated with some unknown values, basically garbage values, and say I wanted to create 100 of them. But the result of this action is that the new operator returns the address of the first integer in memory. So basically, this is what this new operator returns. It returns the address. In my case, this is 7, just happens to be 7. Number 7 is the memory location, number 7. And here I have created a whole bunch of integers, say 100 integers, or however, how many integers the user wants to create. And therefore, in order for me to retain and keep track of these 100 integers, if element count indeed is 100, right? I need to say integer pointer in, I don't know, name it dynamic array maybe, right? And say equals new integer. So basically, in order to retain the result of that dynamic memory allocation, I need to have a pointer variable which will say, okay, I will remember the address of that first integer. Our responsibility in addition to this is actually to also retain the element count, because if we lose that element count, our program no longer knows how many elements we have allocated, and that could be problematic if we try to work in the legal range of numbers that we have created.